In this video I'll be showing you how to solve this problem. 3 to the x power equals 2x, or 2 to the x minus 1 power. So before we do that, I just want to remind you of what we've already done. Is when we solve exponential equations, there's two different approaches that we've used. So first of all, in a case like this, notice that the base on the left is 2, and 16 can be written with a base of 2. It would be 2 to the 4th power. So let's go ahead and do that. This will be 2 to the 3x minus 1 is equal to 2 to the 4th power. So once we have our bases equal, the only way these two expressions could be equal is if the exponents are also equal. So that must equal that. So we would say 3x minus 1 equals 4, 3x equals 5, and we would get x is equal to 5/3. Now there's another approach that we can use. So go ahead and look at this one here. Now you might want to try to solve this one before I do it, but I'll remind you, I'll go ahead and do it now. So first of all, when I look at this one, I can see that there's an extra part here. In fact, if I could just ignore the 3 here, I would have e to the x power equals 12. That's the 3 parts of an exponential equation. And the only way I can solve that is if I switch forms. So the first thing I need to do is get rid of the 3. Well, since it's 3 times e to the x, I can divide by 3. And I'm going to get e to the x is equal to 4. Now I certainly can't write 4 as e to some power, certainly not easily. And so at this point we would switch forms. So it's not like the one I did up above where I can get the bases to be the same and then I set my exponents equal. In this case, the only thing I can do is switch forms. In fact, anytime you have a variable in the exponent, this is often going to be the approach that you're going to need in order to solve for x. So if we change to log form, this is a log base e of 4 equals x. Remember, to check this, you can say, all right, I call it round the world, it's e to the x power is equal to 4, and notice that's exactly what we have up above. Now we don't normally write a base e log this way. We would want to write it as ln of 4. Yeah, I'm going to go ahead and use the parentheses. Equals x. And so when you find the natural log of 4, you'll get 1.3863. Notice I'm going to go to 4 decimal places. Now I want to remind you, in either of these problems, it's easy to check your answers, and I'd certainly encourage you to do that on any test. So if you take 3 times e to the 1.3863 power, that should equal 12, and you can verify that for yourself. It does work. All right, so let me erase all this stuff. And we're going to go ahead and do the problem that I mentioned at the beginning here. Give me just a minute here. All right. So you'll notice that I basically have 3 as a base on the left and 2 as a base on the right. So this doesn't fit the 2 strategies that we talked about where we try to get either our bases to be the same. We can't do that. And we can't just switch forms. We have 2 exponents, 2 bases with 2 different exponents. So we're going to have to do something different. Now, one of the things, a property that we used when we were solving logs was if you have log base b of m equal log base b of n, if that's true, or it's really an if and only if statement, then m equals n. So in other words, if you have the same base and you have two logs that are equal, this part here, we call these the arguments. The arguments must be equal. But it also goes in reverse. If you have two numbers that are equal, you could take the log base b of both sides, and that's just like what we've been doing throughout the semester. You do the same thing to both sides of an equation, and so that's not a problem. So we're actually using this property, and we're going to take the log of both sides. So it'll be the log base 10 of 3 to the x equals the log base 10 again of 2 to the x minus 1. Now what that enables us to do is we can get those exponents out of there using the power rule. Remember, that's one of our rules for logarithms, one of our properties. So I'm going to go ahead and I'm going to move this x out front here and this x minus 1 out front here. Let's do that. And we're going to get x times the log of 3 is equal to x minus 1 times the log of 2. Now keep in mind, x minus 1 is a binomial. And so it's that binomial times the log of 2. You've got to have the parentheses here, or it's going to be wrong, because we're going to have to distribute x minus 1 times log 2. In fact, that's what we want to do next. So we're going to get x log of 3, x times the log of 3 equals, and then here I'll do x times log 2, x times log 2 minus 1 times log 2, that's just log 2. And so all I did was distribute. I did x times log 2 and I did a minus 1 times log 2. Remember, log 2, that all goes together. So now we're trying to solve for x, and so we need to get our x terms on the same side. So I'm going to have to subtract this log here from both sides. So when I do that, I'm going to get x log of 3, I'm going to put parentheses around that 3, minus x times log, oops, that should be a 2 there. I made a mistake on that part up above. Hold on a second and I'll fix that. And this should just say log x log of 2 minus log of 2. Oh, right. So we have x log of 3 minus x log of 2 is equal to minus log of 2. So again, all I did was subtract that x log 2 from both sides. So now I want to solve for x, so I'm going to try to get x together next, or x by itself next. I can factor out an x for these two terms. It'll be x times the log of 3 minus the log of 2 is equal to the negative log of 2. So finally, all we've got left to do is to divide by the log of 3 minus the log of 2. We'll do that on both sides. And finally, we get x equals, now we need to put that into the calculator, and when you do, let me just double check my work here. Yeah, when you do, you get negative 7 point, oh goodness, I can't write here, negative 1.7095. So this is perhaps the most important step. This is a lot of steps. We could have made a mistake along the way. But it's very easy to check this. We can find 3 to the negative 1.7095 and see if that's equal to 2 to the negative 1.7095 minus 1. So basically what you're going to do is you're going to find 3 to the negative 1.709, and let me do that. You should get 0.1529. And then you're going to plug this into your calculator. That's just 2 to the negative 2.7095. And you'll find that that also is equal to 0.1529. And so the good news, if you do this on the test, is when you get done, you're going to know if you've done it right or wrong. And hopefully if you've made a mistake, you can go back and easily fix it. All right, so that's it for this problem and for this video.